Hello everyone, Quentin Corey from Drive System Design, currently working from home due to the lockdown. So today I'm going to talk to you about setting up a new microcontroller, why we do it, and what DSD has done to make the process easier and faster for everyone involved in a new project. So here in this picture we have DSD's controller board that we've designed to drive electric motors. It's based around Infineon's TC299, which is their top-of-the-line processor, and we've made it so that almost every single input and output is available through one of those connectors. We have a couple at the top and then more at the bottom. So because everything is available, the engineers need to set up the board so that we can use the peripherals that they need for the project. Usually the process of setting up a new microcontroller is pretty tedious. It involves hand-coding in C and then a lot of headaches. You might also be using one of those rapid control prototyping units, but those are usually fairly expensive. And with this solution that we can offer you, the price will be down and it's going to be a lot easier. So we know that we don't want to code in C, and we know that the controls engineers are fairly good with Simulink, right? So what we've done is we've created a Simulink interface to streamline the whole process. You just drag a few boxes in your model, and then in a few minutes, depending on the complexity of your project, you might be set up and ready to go. So I'm going to show you um, how easy it is with a small example. So I'm going to create a very small application that blinks an LED, receives a CAN message, and from the CAN data, we change the duty of a PWM signal. Very easy. So I'm going to start by doing the initialization. I'm only going to do the CAN because I don't need to show you everything. So with this, we initialize our CAN, drop a few bucks, select the settings we want. Here we have a CAN message. I'm going to call duty, receive 1 byte of data, and that's it. My CAN is set up. That was really easy, right? So now I'm going to create a function call. So this is a timer that runs every 100 milliseconds. Again, calling a function, and then what we'll do, we'll read a CAN message every 100 milliseconds. So here we have another function call, a trigger more likely, that tells us when a new CAN message has arrived. So I read my data from the message duty, link it to my input, my output, and here it is. I've set up my signal, my model to read a CAN message. So here's the whole code for the application I wanted to do. It took me about 10 minutes to do. Set up the CAN here, and then here set up the timer to generate a PWM signal. And then in my main application, toggle an LED, read my CAN data, and then do the math to output my PWM signal. Easy, right? So I'm going to show you my little setup here on my living room table. So, oh, sorry. I've got my debugger, the control board with the code running, my little blinky LED, CAN case for the CAN communication, power supply, kitchen, and here I've got the oscilloscope, so you can see the PWM signal. Here I've got busmaster that I can use to send my CAN message. Here I've sent my CAN message with the duty is set up for 50%, and I change it to, let's say, 20%, and here it is in real time. And we go to bigger duty, send the message, and here we have 95% duty or something. So here we go. That was easy, right? So in about 5 minutes, I've shown you how to set up a controller to input a CAN message and output a PWM duty. So we can do the same thing with all the different peripherals, the ADC to read analog signals, outputting the PWM signals for your motor controller, digital I/O, etc. All of this is very quick, and maybe I'll show you in another video soon. So I really hope you found this interesting, and then see you for the next one.